Okay, so I've had several people commented that they would like to see me improve this power supply, and in actual fact I'm going to have to pull the whole thing apart. So what we actually have here is somebody has put together two common power supply boards and put them into the one case and kind of connected them together. But a lot of these solder joints here are very poor, ugly looking, and in order to connect those together they've actually hooked a piece of wire up here between this probably an MOV or whatever that thing is, um, and they've soldered it onto the lead of that, and so obviously those boards weren't actually designed originally to be connected together, but they did that anyway. And they've got this power switch on the front here, which unfortunately is kind of a weird thing with a little flange on it. I was hoping that this would be a normal switch, with like a nut on it internally, so I can remove it and actually put another switch on there with a little LED in it, but I don't think that that's going to be practical. I'm not sure. I'm going to have to pull the whole thing apart to see what's going on. I do know that this board underneath here, this is where the three big relays is, that actually switches the output between the different outputs here. And already on there was three really bad solder joints that I've actually already resoldered before. So I'm going to have to put a switch on the back for the actual power, and maybe use this switch here just to switch the outputs. So I could potentially replace this thing here, which is where the power input is coming in, with one with a switch on it. But there's also space here, so I could just drill a hole and like use one of these kind of switches on the back to turn it on and off, which is probably what I'm going to do, but I'll have to replace those little skinny leads. This is a 10 amp switch, so according to what it says on here, 10 amps at 125 volts, 6 amps at 250, with thicker wires like that. Okay, so I've got this loosened. Now this is a separate little switch mode power supply board, which is also fed with the 125 volts, and there is a capacitor on there. And I've got this discharge capacitor discharge pen, and I'm just going to put it on there. And I don't think there's any voltage left in it, but just in case, I don't want to get zapped. The little LED didn't come on, so alright, it should be safe. And let's have a look now. Let's get this unplugged. This thing is soldered on, which again, a bad solder joint there. I mean, it's probably connected, but for some reason they got a thin piece of wire going to there and a really thick piece of wire going from there. I must investigate what is going on there. Okay, so you've got to see this. So we have the power coming in through this connector at the back here. This is neutral and this is line or active, and this active line actually goes through this switch, which is on the front panel. It comes out and it goes over here. So this is the entry point of the AC. then they decided, because it has two complete separate power supply modules in here, instead of putting some sort of connector there that could handle two wires, they actually decided to solder the wire to the leg of this protection MOV or whatever it is device, and they did the same thing at the one at the top here. And then now there's a trace over here on the PCB, which is a fairly fat trace between the two, so I guess it is okay, but it's not very professional as far as I'm concerned. And then you see over here, it goes in out of the board here, and it's got L, right? This is line, this is the active, and this here is a little 12 volt power supply board that actually is mounted in the front there, that actually also has a little switch mode power supply on it that actually provides the power to the electronics on the front panel, you know, with the buttons and the controls, which is over here. And but look at what it says on the board here: neutral and line. And where is the red wire going that is actually active? It's going to the neutral. It's back to front. And the line is a thinner wire that goes to is connected through here with another bad solder joint with the actual main input. And the solder joints on these wires are really bad. I'm going to have to pull it apart and actually improve that. And I'm going to have to desolder these wires and put them in the right place, because they are back to front, which means, you know, active is actually going to where it's supposed to be neutral and so on. Now it is working, but that is a safety issue. Okay, so I have found out that the power supply has 3 relays in there, but in independent mode none of the relays are activated, so they are using their normally closed outputs, and that puts the outputs on the two, the channel A and channel B, or channel 1, channel 2, whatever you want to call it. So, and I also determined that these relays have to be turned on in a particular order, and you can tell that when you're using the power supply and you switch to serial or parallel mode. It takes several seconds before you actually hear the clicks of the relays, because I found out that if you got 2 of the wrong relays activated at the same time, you would actually be connecting the output of one of the controller boards together, so you'd be short-circuiting it in actual fact. So in other words, to make a long story short, I was hoping that I might be able to control the relay coils, you know, with an external switch, and that it would never turn on until I push the switch, but that is not going to work. So instead I have decided to buy this relay board that we are looking at here. It has 2 outputs. Remember, we got 2 switch mode power boards, so I will feed the outputs of both of them through this relay board, and then to the actual 3 relays that are currently on there already, and hopefully that we control with it's a 5 volt one, so we can take the excess 5 volt output. There is one socket that is not used, remember. One is going to the USB-A socket, but the other one is not used, so we'll intercept that one, get 5 volts from there that we can send to a switch, and then the switch can control these 2 relays to actually turn the output from the switch mode controller boards on or off. And it also has a couple of LEDs on there, so we can actually desolder one of those, and the switch that I'm using has an LED built in, and I will connect that LED to the actual controller board with 2 little wires, and I think we might be in business then. But I have to wait till this thing comes, and I don't know, sometimes it can take 3 weeks or so before they deliver. So as soon as I get those, we will continue the video. And until then, let's wait and see what happens. Okay, so here we are. I have prepared a few things. I put some little fork lugs on the outputs or the power supplies, and I have made up a little board which is going to be mounted on, actually like this, on the top here, with these relays on it, and these things are going to be connected to the relays like so. And I removed the power switch which was previously on the front panel right here. This is the one here, which I have put a different type of switch on there with an LED in it, which we are going to be using for output. So if I turn it on, the little light will come on in there and it'll show that these things are active, and if I push the button up, then that's the idea. That's what we need. I put a little lead on there with a little plug for the light, and the wires over here, I put some little ferrules on there. You get those in a little kit like this. See, lots of them. And you use the pliers that came with it in order to crimp them on, which is over here. Alright, so I've done that already. And again, this is going to go to the, you see there used to be an LED there on this board to show when the relay is active, and that is going to be plugged together, which will light up the little LED in the switch here. Okay, so this is all low voltage stuff, 5 volts, so I don't have to put any heatsink tubing or nothing on those little leads there. There's nothing, no high voltage stuff there. And these guys here, they go into these, they go into this thing here. So that's why there's little ferrules on there, because I don't like poking wires directly into those, because they tend to come out, and that's not a good idea. So that is that. So we got that ready. And then what I did was, as I said, I'm discarding this on-off switch that came with it, but I mounted an on-off switch on the back here. Okay, it'll show up on the other camera there, so on, off. This is the only place to put it, and it's not so bad to have it on the back, because you can just leave it on, and you can now control the output with the button on the front panel, so good for that. Now, so what we're going to be doing is, we've got these are the outputs for the power supply, and they end up going to this board over here with all the relays on it, and the relays actually will either output, the power board 1 to that one and board 2 to that one. When it's on independent, when you put it on serial, it'll put those two through the relays here. They will be put in series, but then the output comes out of here, so you can get double the voltage, like 60 volts. And if you put it on parallel, it'll take these two and put them in parallel. Again, the output comes over here, and you might get 30 volts at much higher current than what is available normally, because they're in parallel. Okay, so Then the other thing is that most of these power supply boards here are completely identical. There's two of them, separate ones, and when you use independent, the outputs are completely independent. These ground lugs are not even connected together, so which is actually good. So you can use as two completely separate power supplies if you want to, although you can connect the grounds together if you want to, but then you might as well just put it in parallel and use these outputs. So on each board there is a little socket over here which has 5 volts on it, and in actual fact the top one had a little lead on it that goes in there like so, and that actually feeds that 5 volt 2 amp USB socket, and which is, but the bottom board has the same socket on it, but it is not used, so therefore I'm going to use it. I made up a little plug for it that's already plugged in, and I'm going to be using these two again. It's going to be powering this board over here. It'll be plugged into the power input on that relay board, and so these relays are actually 5 volts. That's why I got this one, because I plan to use a 5 volts. The internal relays here are actually 12 volts. The only kind of drawback with the 5 volts is that they draw, I think, 190 milliamps or something. Almost 0.2 amps each, so that's going to be like, almost 0.4 amps. But obviously you can draw 2 amps out of there, so that's well within its capability, so that should be fine. Anyway, so I think we are ready to put all this together now. So let me get, oh, and so actually what I've done is, normally this screws into here, on top of this board here, and then this board over here actually sits on top of that with a little screw. But what I've actually made up is, I also got a little metalworking shop, but you could actually just use these standoffs. Like I've got a kit of different standoffs over here, and I've screwed a couple of those together, and you could actually use that and just screw that in here like so. But I decided, I had some scrap metal laying around with little rods, and I machined the ends off and put some threads on it. So I'm going to be using these. They're going to screw in there, and then the relay board is going to go on top like that, and it'll just fit inside of the cabinet. And of course, this goes on the front like so. Alright, so that is how we are going to be mounting it. But first things first, we have to solder some wires, and I've made up some wires over here. Also, these are going to come from our relay board, and these wires here have to be soldered on this board over here. You see there's 2 empty holes there where they're going to be soldered in, and this cable here is actually meant to be for, it's nice and flexible, and it's silicone. It's actually meant to be for probe leads, but the wire in there is thick enough to handle the current, so we're going to be using that. So I think the first thing that we will do is to solder on these. So this is the power coming in, through the wall socket. It has to go to the switch over here, and then this one over here is the power going into the board here, but it's in parallel with the other one over here, so therefore we can solder that to that switch. And in order to do that, this is going to have 120 volts on it, so let me see where my, oh, here. I'm going to be wanting to put some, let's see what size I need, some heat shrink tubing. Is this too big? No, I think that'll work, and it'll go over there as well. Let's use the blue one. Yeah. Alright, so I can snip this in half, like so. I can slip it over top of this wire here, and over top of this wire there. Turn on the soldering iron. Let's have a look, some solder. This one can go on the bottom here. Now somewhere I've got a little clamp. Yes, there it is. I want it to come out like so. So we've got power coming in. Now over here, this one is supposed to connect to this little board, but it was connected to neutral instead of to the line input, and this fat wire probably came with the power supply, and it is actually too large for that little board. So I'm going to remove this fat wire here, see if I can get to it. Yep, that's good. And I have a little piece of skinny wire. See, this wire, the neutral wire is actually very thin, but I found one that is it's only a little bit thicker than that one, but plenty thick enough to go in there. We're going to, come on, a bit more. We're going to use some solder wick over here to wick out that solder in that hole. I think that's good enough. You should be able to stick that wire in there. I'm going to put it on the side. Let's see if I can get that from underneath. This is old wire that I'm recycling from something, so again, some flux on there. Always helps with old stale wire. Yep, that's a good one. Okay. All right. Yeah, that's good enough that way. Okay. And then we got this one here, goes to neutral. All right, so we've got this connected. Here, if this thing is going up here, and this one is my screwdriver. Tighten that up a bit better later on. I'm using the normally open connections here. Right, this sits over here, and that has to go down to the board there. Has to go down to there, and I think they are approximately the right length. Okay, so these have to be connected. Actually, what's the point? I'm better off to leave those off for now. This one is going over here. Steady that thing up a bit like that. Now, this little plug, I actually marked all the plugs in case I get confused. You put little dots on them and stuff, just in case. You know how it is. It's easy to get confused and hook it up wrong and blow something up. Alright, this goes there. So let me see now. These all go to the front panel. I used a little piece of plastic from an old project box that I'm no longer using, and drilled some holes in it so that I could mount it like that. Now, these guys over here are kind of confusing. They're all sort of twisted and mangled, so I put numbers on them. 1, 2, 3, 6, and I put numbers on the back here so that I can remember where they go. Okay, so this is power coming in, but it also goes over to the switch. Then it comes out of this wire here and it goes to both of those channels if the switch is on. That is what we want, yes. Okay, that should do it. Alright, let's have a look if I wired this up right. Okay, well here goes Alright, well, that was weird. That little relay board, I kind of reverse engineered the circuit here. This is kind of what it looks like. It had a DC plus, a DC minus input, and then there was a COM input channel 1 and channel 2, and it had a little jumper here in order to select whether you wanted to respond to high or low signals, and I had it set to high, and I took the DC plus and DC minus from that socket on that second PSU board. The first one is actually going to that USB-A port on the front, so the second one wasn't used, so I thought that was convenient. You use 5 volts from there. And what actually happened was that as soon as I turned the power on with the switch to connect channel 1 and channel 2 to pull them high, the power supply unit that the DC plus and minus was connected to decided to shut down. And as soon as I turn it off again, it would be it would be running again. I have no idea what is in this circuit in order to make it do that. So what I did was I actually removed all these components from the board, and all I got now is the relay and the diode, and I've got channel 1 and channel 2 are both connected because both relays need to be turned on at the same time, and I have the COM port here directly connected to the bottom there of these relays, and the channel 1 channel 2 is connected together, but they're both going to the top of the relays, and everything is sweet now, everything works. So no idea what happened there. So let's have a look at it. So I can switch it on. The switch that I put at the back, and the voltages come up, and right now the little switch there is not on, so I should not be measuring any voltage. As you can see, it's just picking up some noise. Nothing. Okay, so now I switch the switch on, and we have 5 volts, and that port is as expected from that, as you can see on the display, and I have 3.3 volts on that one, so that's working. And as you can see, the little light comes on the little power switch there. So now I can disconnect the ports on and off. However, what I should have probably realized is there is a board in there that has relays on it already, which actually connects these two ports, these two PSUs in series. In other words, if this is minus, then the plus will be connected to this minus, and that will be the plus. So you have double the voltage, but it doesn't actually do that. It actually puts it out on this port. This is what, if you push series or parallel, it comes out of these ports, and as you can see, it is marked series parallel. However, when I do that, takes a second. Okay, I just heard a click, and now it says it has 60 volts, and indeed that is what it is. You can see on the top left of the screen there. But if I turn the power off, I mean the output, it goes to 0. And it's the same for parallel. It will only display on the display here if this little power switch is on. Now we've got 30 volts, but you can actually draw 20 amps out of it, because the two power supply boards in there are now in parallel, so that they can both supply like 10 amps each. So turn that off, and the display goes to 0. Now it doesn't bother me too much, because I really wanted to be able to disable the power on those two when I'm using the two separate power supplies, and when it's independent it does work, and I can actually adjust, the voltage. So let's say 6 volts here, and then I can turn the power on, and now we should have 6 volts there. So that is working correctly, and I based it on the fact I'm actually put my new relays in series with the two power supply boards. But obviously when you are putting it in serial parallel mode, there's that little board in there that also supplies the 12 volts. It must be actually measuring the voltage there and displaying it on the screen. But of course when I turn the power off, and in this mode it's not a problem, because it is actually getting the voltage from the actual separate PSU boards. So another thing about this, of course, is that this is a switch mode power supply, like all of the cheaper Chinese supplies are. And the only reason that I wanted this one is because you can put it in series and parallel, get more current and more voltage as well. And I've got two separate voltages, which sometimes I need. But the output of it, there's a little bit of noise there. I think it's about 70 odd, 70 plus millivolts usually. It does not seem to change with current. Like, it doesn't matter whether you're drawing 1 amp or 10 amps. It seems to be the same. So some of those is probably common ground noise or something like that. However, I've been experimenting with, I made up this little choke, and this thing here, I don't have a big enough choke here to put, because the wire has to be fairly thick, to get up to 10 amps or 20 amps even if you connect it to that one. I need to get some bigger ferrite cores and do some experimenting, but this one here, it only has like 23 microhenries, and 1, 2, 3, 4, 5. I could only get about 6 turns on there, and you need at least 12 or 14 turns, and it's be good to get about 100 microhenries, about 4 times as much. So I will continue to experiment with that. I made that up, put some little things on there. I can actually connect it to the output over here, and if I put this on already, even though it has not quite enough inductance, it's already reduces it to 50 odd millivolts instead of 70 odd millivolts. So I think if I had a proper choke ferrite core here, where I can put like 12 or turns of wire on there or so, then I think this would make it nice and quiet, in case you need that. I don't have a great deal of need for a bit of noise on the switch mode noise on the power supply. Doesn't really hurt the circuits that I normally work on, so it's all digital stuff. And I do have my other power supply, of course, which you can kind of barely see in the background over here, which is a better, more expensive power supply. It has only maybe 20 odd millivolts of ripple, so I can use that one. But anyway, that is so far what I've done, and I'm actually reasonably happy with the results so far. I really feel that every power supply should have a switch, to be able to switch the output on and off, because if you're working on the circuits, you want to be able to disconnect the power. You don't want to have to unplug the multiple banana plugs each time and plug them back in. So that's that. I think I will probably revisit this in the future, and as I said, I'll probably make up my own custom board if I can find some 20 amp relays, or 15 amp would probably be enough. Although not for this one. This one here, if I'm going to switch this output off, it can go up to 20 amps. So I would definitely need at least one, probably a 30 amp relay or something. But 15 amp relays would do for those two. And I might even, put on some extra chokes, like if I'm finished experimenting with this thing here, and I found some decent ferrite cores. The sort of thing you'll see inside of these power supplies. They usually have one large core in there, but you need to put some heavy duty wire on there, and what you're really looking for is a circuit that filters both the ground and the positive voltage. So the sort of thing that you're looking for is like the positive voltage and the negative voltage both go through the same choke there, and a capacitor before and after. There's like a filter arrangement, and that would improve the output quite a bit on that thing. Anyway, I will see you guys later. Don't forget to subscribe and like and all that kind of stuff, and we'll do something else next time.